Before we get started on the actual notes, I want to review with you something that you learned a long time ago. If I have 2/5 plus 1/5, that is 3/5. When you're adding fractions, if the denominator is the same, you're able to add the numerators together. Notice that the denominator does not change. You simply add the numerators together once you have a common denominator. So if I was trying to do 1/3 plus 2/5, we can't currently add those together. We need to get a common denominator. And what you learned a long time ago is that the common denominator is 15. So what we're trying to do is create 15 on the bottom of each of these fractions. But what I want you to think about is that what we're really doing is we're getting 3 times 5 on the bottom of both of those fractions. So we currently have the 3, we would need 5, so we would have 5 on the top of that fraction. This one we'd multiply by 3 and we would have 6 on the top of that fraction. So you'd have 5/15 plus 6/15, which would be 11/15. But what you really have is 11 over 3 times 5. That's kind of what we're going to be doing today. Now we're going to start with that first type. So if the denominators are the same, you can add the numerators. So in number 1, we've got 4 over 3x plus 5 over 3x. The denominators are the same, so we can add those numerators together. 4 and 5 is 9. Now, once you add them together, do take a moment to see if the number parts of this is all multiplication. So could this be simplified? What is 9 divided by 3? 9 divided by 3 is 3. So this one becomes 3 over x. So if it's a problem like this with no addition or subtraction in those denominators, you can simplify the answer. Now in our second example, there's subtraction in the denominators, so we're not going to be able to simplify it like that. But x minus 4, the denominators are the same, so we can do 5 minus 8. 5 minus 8 is -3 over x minus 4. All right, there is a problem like number 3 on your assignment, but first I would like you in this space right here, we're going to do an additional example that's not in your notes, but we're going to skip some of the other examples, so it's okay. We're going to do 5 over x squared plus x minus 20 plus 2 over x minus 4. Now the first thing I want you to notice is these denominators are not the same. The first denominator can be factored. So we are going to take this thing and factor it. We're looking for two numbers that multiply to give us -20 and add up to 1. That would be 4 and 5, and I believe the 4 would need to be negative. So that one is going to become 5 over x minus 4, x plus 5. And we still have plus 2 over x minus 4. Now I put parentheses around the x minus 4 because I know that I can't factor that anymore. That is the factor x minus 4. Now we're going to do what we did in this example up here. We are going to make the denominators match. So currently, and I like to use colors for this, so we have x minus 4 in both of the fractions. We need an x plus 5 in both of them. We have it in the left side, we don't have it on the right side. So we're going to stick an x plus 5 here. But you can't just stick something into the denominator of a fraction. That changes the fraction. You have to also multiply the top by that thing. And if you remember old school getting common denominators, we multiply the top and the bottom by 5 here. We multiply the top and the bottom by 3. So you're multiplying the top and the bottom by whatever factor you're trying to stick in the denominator to make the two denominators match. All right, our common denominator is x minus 4, x plus 5. So once you get the common denominator, don't do anything with it. It's going to stay x minus 4 and x plus 5. On the top, we can now add these things together. So we have 5 plus, we can distribute here, 2x plus 10. Then simplify. Our final answer is going to be 2x plus 15. Do you see where the 15 came from? The 5 and the 10 can be combined over our common denominator, x minus 4, x plus 5. Let's look at number 4. Number 4 is a little bit more complex, but there is a problem like number 4 on your assignment, so it is definitely worth doing. There's a couple things to note here. The first thing is both of these can be factored. So I've got x plus 1 on the top. I've got a 1 over here. I'm just going to spread it out a little bit. This is minus. Subtraction can be a little tricky. So what we're going to do is we're going to change the subtraction to adding the opposite. So I'm going to change this to plus the opposite, and we're sticking that negative on that second numerator. This is an incredibly important step so that you don't lose a negative. So make sure you change your subtraction to plus and then stick the negative on the following numerator. I believe number 6 on your assignment is like that. Make sure you notice that minus. We will definitely talk about that when I see you tomorrow. Our first denominator we need to factor. We're looking for two numbers that multiply to give us 9 and add up to 6. That would be 3 and 3. So we've got x plus 3, x plus 3. Our second denominator, that's a difference of two squares. X squared is the perfect square of x. 9 is the perfect square of 3. So that factors into x plus 3, x minus 3. Now we need to see what do the denominators currently have in common and what are they missing? What do we need to fill in? So I see x plus 3 and x plus 3. So there's a match. Here I've got x plus 3 and there is not another x plus 3, so we need another x plus 3. Then in the second denominator, I see x minus 3. I don't have that over here, so I need an x minus 3 over here. Okay, now the good news is the problem on your assignment is not going to involve double distributing in the numerator. It's going to be a little bit simpler than this. But if we can handle this problem, you can handle anything that is similar to this, but slightly simpler. So our common denominator, do you all agree? We have the orange, x plus 3. We have the pink, x plus 3. We have the blue, x minus 3. And if you need to go back and check, there's x plus 3, x plus 3, x minus 3. I've got all three of them in both denominators. So my common denominator is x plus 3, x plus 3, x minus 3. The order that you write those does not matter. In our numerator, we need to double distribute and simplify. So x times x is x squared. X times negative 3 is negative 3x. We've got 1x and negative 3. Looks like I need to extend this because then I have to do negative 1 times x and negative 1 times 3. And then we can simplify, combine our like terms. So we've got x squared on the top. We've got negative 3x, positive 1x, and negative 1x. So that's going to become negative 3x. Negative 3 and negative 3 will make negative 6. And our denominator is x plus 3, x plus 3, x minus 3. Now you could write that denominator as x plus 3 squared, because there's 2 of them, times x minus 3, but you don't even need to go that far if you don't want to. You certainly can, but I'm not going to require that you take that extra step. This would be considered the final answer in my book. If you feel like you've seen enough, go ahead and start working on worksheet 6, 7.4 worksheet A, that's worksheet 6. If you want to see the setup one more time, let's do number 5. Let's get number 5 set up one more time. So I've got x minus 1 in my numerator, and then this denominator needs to be factored. So I'm looking for 2 numbers that multiply to give me 3 and add up to 4. That would be 1 and 3. This one's nice because it's plus, so we don't have to deal with that negative. Remember, anytime you have a minus, like over here in number 6 where this minus is here, change that to plus and stick the negative on the following numerator. We don't have minus in number 5, so we don't have to worry about that. This denominator is difference of 2 squares. It factors into x plus 3, x minus 3. Now I need to check to see if my denominators match and what each of them are missing. So I see that they both currently have an x plus 3, so that matches. My left one has an x plus 1. My right one does not have the x plus 1. So it needs an x plus 1 to make those denominators match. And when you write it on the bottom, you have to also write it on the top. Then I look, I've still got this x minus 3. I don't have x minus 3 here, so I need an x minus 3 in this fraction. Okay, now x minus 1, or sorry, x plus 1, x plus 1, x plus 3, x plus 3, x minus 3, x minus 3. So my final answer is going to have x plus 1, x plus 3, x minus 3 as the denominator. Now the order that you write those doesn't matter. So you could write x plus 3, x minus 3, x plus 1. The order of those parentheses does not matter at all, as long as one of the parentheses has plus 1 in it, one of them has plus 3, and the other one has minus 3. The order doesn't matter. If you're going to finish this problem, you would need to double distribute on the top, distribute on the right numerator, and then combine those like terms. So again, if you feel like you're good now and you know how to set these up and do these, go ahead and start working on your assignment. If you want to see this problem fully completed, keep watching. I would double distribute to get x squared minus 3x minus 1x plus 3 and x squared plus 1x. When I combined those like terms, I've got x squared and x squared, so that's 2x squared. I've got negative 3x, negative 1x, and 1x, that's minus 3x. And then I've got a plus 3, and my denominator is whichever order you want these in, x plus 1, x plus 3, x minus 3. That would be my final answer. We aren't yet going to do problems like number 6, so I'm going to skip number 6 for right now just to keep this video as short as possible. So get to work on 7.4 worksheet A, which is worksheet 6.